Hello everyone. I wanted to show you a little something that I've been cooking for the last couple of weeks. So this is a tutorial that covers all the essential topics of calculus in a printable format. It's a little hard to show on paper, so I have it open on the computer. Okay, so link in the description. But yeah, this is a free tutorial that explains the main ideas of calculus. How I wrote this is I looked through the math book, the calculus, the math and physics book, and the last third of it, so about this, is the calculus part. Maybe 200 pages. Now that's a lot of details. So I cut it down to 25 pages using a small font and 2-column format. And everything you need to know, all the essential concepts are here. So functions and their properties. You know, how does a function change? How do you, if you have a function over time that accumulates some quantity, what is the total of the quantity? The technical terms for the change of a function is derivative, and the accumulation is called an integral. Okay, so those are key ideas that you need to know. Every engineering discipline is built on calculus. A lot of scientific concepts require derivatives and integrals. The reason why I wrote this now and not some other time is because I need it for the statistics book. So in order for the No Bullshit Guide to Statistics to be self-contained, there is these appendices that introduce Python, pandas, and calculus is required to do math with continuous distributions. I don't want to be like, hey, you should know this from somewhere else, you know, like what if you don't know it? So this is the tutorial I wrote. Okay, so this is the PDF. It's 25 pages, but you know, I tried my best to condense it. If you have feedback which things I could cut, let me know. But my best effort to compress got it down to 25 pages, which is pretty good compared to 200, you know. And yeah, so it's really good if you print and read on paper. If you read on a desk on a computer, it's a little bit more awkward. And very important, if you click here, the bit.ly link, it will open the computational notebook. So ever since I started working on the stats book, I realized that something that works really well is if you combine the math. Okay, so let's look at integrals, for example. Okay, so you have some math definitions. You have visual examples. That's great. Everybody likes that. But an extra layer, when you say what is the integral, I can actually give you a Python function. Sorry about that. A Python function given the function f and the limits of integration, we can actually do what the integration procedure does. So you can see the code that corresponds to this integral. Actually, it's to this one. So that's a nice first step. You know, if you can compute it in 1, 2, 3, 5 lines of code, it's great to understand. You know, you get a number, and there's also some nice visualization of what that does. So yeah, all of that is here. If we jump to the place, integrals. Let's make sure this is defined. Here is a function. And you get integral. Okay, so this is important, that the one we need is when we use a lot of, yeah, it's a procedure with a parameter n, and the numbers get is exact only when we use a lot of rectangles. So it's kind of a teaching device and a computational procedure. So yeah, the default parameter is 10,000. So if you didn't specify n, it would do the right thing. Okay, so I won't say much more about this, except, yeah, so these are the standard topics: limits, derivatives, integrals, sequences and series. You will find this in every calculus textbook out there. What is special here is this computational aspect, that not only is there graphics and math and, you know, obviously text, but the computational aspect really helps. Like, if you, without going through all the details, everything I explained in the tutorial is also backed by something you can run. And another aspect that you know, I'm a big fan of is this library called SymPy. So there you go. So SymPy. So some of the calculations you can do with pen and paper, you know, you can also do on a computer. So we're talking about symbolic math. It's not numerical approximations. You get exact answers. So here is a quick example. If you, this is the math expression, the number e, Euler's number, is defined as the limit of this expression here. And you can literally do this calculation in SymPy and get an exact answer. So this is computing the limit as n goes to infinity. Like, this is a theoretical concept that you could never do in Python in a numerical calculation. You know, you would have to write a for loop that goes to infinity, but in SymPy you can do the theoretical construct. Okay, so this is it, standard calculus, but with extra SymPy and extra NumPy, SciPy, all the good, you know, modern stuff that you will need in industry. And SymPy, you can think of it more as an educational tool that you can check every answer. You can do all kinds of calculations that you would normally would take you hours to do by hand, but you can do them in a second on the computer. Where do you find this? Assuming you're interested, you're like, I want to read 25 pages of 2-column dense math stuff, you will find it here. So minireference.com, there's a section called free stuff. I already have a mechanics tutorial, linear algebra tutorial. This was the missing piece, calculus tutorial. If you click here, you will get the PDF. And for the notebook, it's bit.ly, it's linked here. It will open the notebook either in the cloud, or you can download it and play with it locally. Also, this calculus tutorial is going to be Appendix F in the statistics book. So this will be appearing in a couple of places because calculus is important. It's kind of a big deal. Check it out. Let me know if you have any feedback. I've been editing it, so this is maybe the 6th draft. The whole holidays and the last couple of weeks I've been working on that, but I'm sure I'm still open for feedback. And if you say what I could add, what I could remove, is it actually good? Maybe it's too condensed. Other examples. Anyway, any feedback, welcome. All right, peace out.